Hey guys, Sharp1 here using the Roblox scripting tutorial. Today I'm going to go over some like a new class in Roblox. The class is BodyMovers. So body mover is exactly what it sounds like. It can move something that is attached to in the 3D space. So like you could attach one of them to a part, and then if you configure it correctly, you can have it move in a certain way. So we're going to go over two body movers today. One of them is BodyForce, and the second one is BodyPosition. So go ahead and go into Roblox Studio, and then go into Baseplate, and then inside of the workspace, create a part. And then you don't have to size it, but if you want to size it however you want. I want to do a square like this. And also make sure the faces, like the surfaces, make sure those are all smooth. Oops. Because if they're studs, then they could snap onto this base plate right here, then it might not work. So up here in the advanced objects in the search bar, type in body, and then it'll show up all of these body movers. There's body force, body angular velocity, body gyro, body position, body thrust, and body velocity. The ones we're going to go over today are body force, body gyro, and body position. So first, let's go over body force, since it's probably the simplest one. So go ahead and double click on the part that you want to put in, and then double click on it, and then go to body force. So the only properties that there are is the name, class name, parent, and then the force. So what this force is a vector 3 value, but it is not a position. It is a direction in this instance. It is asking you to put in the direction you want this part to move in 3D space. The higher the number is in each of these axes shows how much force is going to apply in that direction. So if you just put it in the y-axis, it's just going to go up. But just putting it as just one might not be enough to push it upward. You might have to do something. You might have to do a higher number, like 50 maybe. So all I have to do to see it take effect is go to run. Alright, so it's not doing anything. So one problem could be it might still be attached to the base plate. No, it's not attached to the base plate. But as you can see, it's kind of fallen a bit slowly, possibly because there's still a force going upward. So if it's not going to go upward at all, we have to apply a higher upward force. So let's do 500. It still isn't going up. So let's try 5,000. Oh, there it goes. Oh, way up there. So you don't have to do just the y-axis. That's just how you make it go like straight up or something. But you can go in different directions too. Like let's see. So so if you put it 0, 0, 0, it's not going to go anywhere. But if you wanted to go across the z-axis, you just wanted to go forward, so you just make it 1,000, and it'll go forward in the z-axis. See how that goes. And also, just so you know, these body forces or body movers, these will not work if the part is anchored. If it is anchored, then no body force can interact with it. It'll just stay exactly where it is. No amount of force will be able to change it, so it has to be unanchored. And so these kind of body forces, they can be used to make they can be used in the creation of like guns, like the shooting parts of guns, like for the bullets. This is how some of them are made, and this is one good way to do it. But I like to use a different body force called body velocity, which we will go into on the next tutorial. But today we're just going over these few ones. Alright, so we went over the y-axis and the z-axis, and you can also do the same with the x-axis as well. But you don't have to do just one of these at a time. You can do all of them at the same time. So you can go like in kind of diagonal lines. So I'm going to make the force on all the axes 1,000. So you kind of went in diagonal line. It went this way, and it went that way, and it went upward all at the same time. So it went kind of diagonalized, because it got a split between them, so it doesn't just go in one direction. But to get it to go in a specific direction, you're going to get it to go in a specific direction, you're gonna have to most likely use a script. It's gonna be hard to find these kind of directions in just on your own, though it is possible. But to get a certain direction, like maybe you want it to go in the direction that the player is facing, you could do that. You have to use this one property of the C-frame of the part called look vector, which I'll show you guys how to do right now. It'll be good to learn. So go ahead and create a script inside of the part. Okay. So first I'm going to so what we're going to do here is that we're going to make the body force. We're going to adjust this force thing right here to go in the direction that this part is facing, which is called the look vector. The look vector is a property of the part's C-frame. What a C-frame is, a C-frame is, well, so a vector is pretty similar to a vector 3. A vector 3 is just purely position. Every part has that as well. But what C-frame is position and rotation at the same time, and it has some other properties of it too, like look vector, for example. So the look vector is the direction that the front face of the part is facing, or is looking at. So to find the front face, one way you can do it is go into the surface property and go to the front surface part, and you can change that to motor. See where that little yellow thing is? That is the front face. That shows what it is looking at. So now that we have that, let's go ahead and change that back to smooth. So now to get the look vector, what we do is we just put it as a variable. So we'll make it look equals script dot parent dot CFrame dot look vector. So actually, let's go. I think we should print that. So I'm gonna print what it is. Print look. Let's press run. And here it said, oops, it said 0, 0, -1. Wait, where'd it go? Oh yeah, that's right. Here, let's get rid of the body force for a second. I'll do it again. That's not. Alright, there we go. 0, 0, -1. So that's good. That's the direction it's looking at. But so you can apply this to the body force, and it will go in that direction. But the thing is, as I already saw before, just having one there, that's not enough force in order to actually get it to move. That's not enough. So what you got to do is you got to multiply it. So first, let's create that body force again. There we go. So now what we're gonna do is script.parent.bodyForce equals look times, let's do 800. I just let you know, look vector is a vector 3 value. It's not a C-frame, but this look vector is a member of the C-frame. That's what you know. So the look vector is completely compatible with its body force vector 3 value. Body force dot force. There we go. So now let's run it, and it should just go in that direction. So now if we were to rotate it beforehand, let's see, maybe that way, then when we play the script, it's going to go in that direction. Oh, what? What's up with that? Here, let's see. Front surface. There. Motor. Oh, whoops! I did it the wrong way. There we go. So now, if it goes, we face it that way, it should go in that direction when we play. See, there it goes. So if you wanted to, so let's say you were making this a bullet for a gun or something, you could just you could get the look vector of the player's mouse or something like that, or maybe the direction that the camera is facing, or the direction that the gun is facing, or something like that, and you can apply that to the body force. So that's pretty much it for the body force part of this tutorial, since it's one of the simplest body forces that there are. So let's go ahead and delete that, and we'll delete that one too. So now we don't need that thing anymore, setting that back to smooth. So now we're gonna do body gyro. Actually, we're gonna do body position first, and then we'll do body gyro. So go ahead and type in body in the advanced objects, and then while the part is selected, go ahead and double click on body position, and that'll create it. So you click on it, as you can see there are a few more properties here. There's still the regular class name, parent, and name, but down here there are some other properties. So there is D, MaxForce, P, and then position. So to show you what these all mean, I brought up the wiki page for the body position right up in Google. So at the properties right here, this is what it shows. It says D is sets how much dampening the object has before it reaches its goal. So what that means is that so this body position is going to basically tween this. It's going to smoothly move this part to the position that it shows right here in the position property. So it's gonna try to move this there. So it's gonna move it in a straight line, obviously, unless something's in its way. And it'll be obscured, but it'll try to get there in a straight line. So it's going to go fast, but if you increase the D property, which is dampening, then as it gets closer to its target, it's going to slow down a little bit so it doesn't overshoot it so much. That's what dampening does. And so MaxForce, so as you saw in the last one, the force property, that one, the force property is the direction and how much force it's going to apply to it. But the MaxForce, when you have MaxForce, you don't have to apply such a huge number to do that. But it's also kind of necessary here, because if this position property were both the position it's trying to get to and how much force it was applying, that wouldn't work, because then it wouldn't go to the correct spot. So this will show how much force this body position is going to apply on each of the axes to get to the position that's specified here in the properties menu. So if I only put this as, so here, I'm going to create a body force here so I can kind of show you an equivalent. Body force. So right here, so you can specify the position that you want. So that is about the same as specifying what direction you want this to go in. But the max force is how much force is going to apply on each of the axes. And so the higher the number on each of these axes in body force, the more force is going to apply to get going in that direction. That's kind of how it is. So what you most likely want to do is that you want to set max force to infinite. To do that, you have to use this kind of math function, I guess. So we're going to do this in a script, and what we're going to do is we're going to set up the max force. So script.parent.maxForce equals vector3.new. On each of those, you're going to do math.huge for all of the axes. Math.huge is the equivalent to infinite, and so it's kind of a bit faster than typing in some big number, and it's a lot better than typing in infinity, which is kind of impossible unless you use this math.huge function. And so we're actually going to leave the D and the P the same for now, but we are going to set the position to something. Well, actually no, we're just going to do it how it is now, so I can give you a little demonstration. So right now the position is 0050. So what it's going to do is this body position is going to try its best with the max force that it's given to get the part that it's parented to that position, which is at 00 and 50 studs in the air. So press run, and then it moved it up. Then it's just gonna float right there. It'll stay there until something pushes it down or this body position is removed. As you can see right here in the MaxForce, it says INF, INF, INF. That is short for infinite. But just so you know, you can't type that in manually and have it work. That doesn't work if you type it in manually. You can only way you can get those kind of infinite readings is if you use math.huge. So let's go ahead and stop this again. And then let's increase some of these other properties, like the D property. Let's increase that to like 10,000. See what it does. Press run. So you can see it's going quite a bit slower because, as I said before, the higher that the dampening property is, the more it's gonna slow down the closer it gets to its target. So you don't want to raise the D property too high, or else it'll probably take forever to get there. And see, what is P does again? And so the property of P, that sets how aggressively the object tries to reach its goal. So that's basically going to show how much extra force, I guess, is going to take in getting there. So let's increase that to maybe 30,000. Let's see what it does. So as you can tell, it went quite a bit faster than it did before. That's because we increased the P property. So that's pretty much it for body position as well. Except there are some other functions too. Let's see. So the get last force function, what that does is that if you call that on this, it's gonna give you the vector 3 value of the last position that you gave it, I believe. Let's see. Change the last force. Yeah, that should be right. So it's gonna return the last position that you gave it to move. So let's do that. We'll do script.parent.position equals vector3.new, and then let's do 0, 20, 0, and then after that we're gonna change it to. Actually, after that we're gonna print the last force. So we're gonna do print script.parent get last force. Oops. There we go. So it should print out to vector 3 value of 0, 20, 0. If my 0, 0, 0. That's odd. Yeah, let's try that again. That's odd. Let's see. I'm not sure why it's doing that. I don't know, maybe that's a mistaken one or something, I'm not sure. I don't know why that one isn't working, so I guess I disregard that one for now. But that's all you really need to know for the functions part of it, I guess, because that one doesn't really work, I suppose. Or maybe I'm doing something wrong, I probably am. That just goes to show that everyone makes mistakes. So, let's do this event. So this event, reach target, it says it is fired when the parent of the body position reaches the desired position. So what that means is that when this part of this body position is parented to, when this part reaches the position of the body position, when it gets within 0.1 studs of it, that event is going to fire. So let's go ahead and try that. So let's set this position to 100 actually, so get some time to wait before that fires. And then we're going to do script.parent let's see, that reach target connect function. I don't think we need that. And then we can say print the part has reached the position. Alright, now let's run it. See, now it's done moving, as you can see. Down here in the output, it says the part has reached the position. Okay, so that's all there really is to body position. Body movers are pretty basic concepts, which is nice, and they're pretty basic, but yet they can be pretty powerful. So one more thing I want to show you guys before I end this. We can get rid of the script right now. We're gonna keep this to 50-50-50, and so we're just gonna type in a really big number for the MaxForce. Okay. So I'm gonna keep it like that, but then we're gonna show you the BodyGyro, but after I show you this real quick. There. So let's see if I think I can still rotate this while it's doing this. Yeah, there we go. So as you can see, it is still floating in the air. It's not anchored or anything, and it's rotated. Well, there may be times when maybe you're doing something like maybe you're trying to make some kind of a moving platform that moves back and forth between two other platforms, like maybe some kind of transportation system. I don't know, maybe some kind of hovercraft, and so you're gonna have players standing on top of that. But while these things are floating in the air, these things are still subject to physics, so they can still rotate and stuff if anything hits it. So one way to fix that is you can put a BodyGyro into the part. So go into Advanced Objects, double click on BodyGyro. So once I inserted it, as you can see, it realigned the part so it is facing upward. If I rotate this again, it's going to go back up. See? And so there are some other things here that work the same way. There is the property D, which is dampening, and there's P, which is aggressiveness, and then max torque, which is the same as max force. There's also one other property of it called CFrame, and that is a hidden property that you can only do if you script it. The CFrame property tells the BodyGyro how to rotate the part, so it doesn't always have to rotate it right side up. You can rotate it a different way. So let's go ahead and insert a script into the BodyGyro, and so then we're gonna adjust the CFrame. So script.parent.CFrame equals CFrame.angles. Now this is this is kind of a new thing to you guys. I haven't showed you guys this yet, but this is another thing of CFrame. So since CFrame is position and rotation, you can assign CFrame.angles to tell it to do rotation. So the CFrame.angle still has 3 axes right here, but so let's say we want to set this to a certain rotation in degrees. One way you can do that is you can do math.rad. That returns the number you do in radians. So let's say we want it to turn it in a 90-degree angle. You could do math.rad 90. And so now, since you want to see this exact action, just click on the script and then disable it and then re-enable it. So as you can see, it adjusted the C-frame, and now it is going kind of at a diagonal. It's kind of in a diamond shape now because it turned 90 degrees on the x-axis. But if you want it to go back to setting right side up, just keep it all at 0, 0, 0. There we go. And so you can set this to all kinds of different rotations. You can keep it spinning infinitely if you wanted to. So that's all that's all I have for you guys today on BodyMovers. I hope you guys enjoyed this video, and I hope you learned something. Come back tomorrow and I will show some more BodyMovers like body velocity and body angular velocity, and some other stuff too, possibly. So please thumbs up and subscribe, and tell your friends about this if they want to learn how to script as well. I'll see you guys later.